Welcome to the next part of digital electronics lecture series. We have discussed two important parts. First one is basically on the number system, especially the binary number system. And the second one we have discussed on complements, the 1s and 2s complements. Now in this particular tutorial part, we are going to discuss on the standard form or the canonical form, where we will discuss two important standard forms, that is sum of product and product of sum. So sum of product, which is basically the sum of the mean terms. So if you take an example where we have the three functions a, b and c variables, and the function is written in this format, so we can see here that it is basically the summation of the product of the variables. Here the variables is nothing but the binary numbers, which is forming the gate operation. So this is two level and or implementation. And in the second example, if we see, this is a product of sum, which is the product of the maxterms. So here we have the product which is forming for the different sum terms. So we have a plus b and then multiplied with a plus c and then multiplied with b bar plus c. So this is two level or and implementation. So these two important forms, that is SOP and POS, are basically the canonical forms. The SOP, where all variables appear in each product term, this is the mean term, and canonical POS, all variables appear in each sum term, that is the max term. Now let us take an example of three variables and we will see what are the mean terms and max terms and how they are basically formed. So the mean terms for the three variables, we will have the index with a small cap letter m from 0 to 7, and these mean terms will be written in the product of the three variables in a definite way. Like for example, m0 will be written as a bar, b bar and c bar, whereas m1 is nothing but a bar, b bar, c. m2 is a bar, b and c bar, and so on. So till m7, which is the product of a, b and c. So this is basically the mean term. So when we talk about the max term, we represent the index with the upper cap letter, where we have the capital M 0 to 7, and here we have in the form of sum. So if you have a plus b plus c, we have m0, a plus b plus c bar, which is m1, and these will continue till m7, where we have all the bars summation. If we observe these two mean terms and max terms relationship, we can find out that the mean term is basically the complement of the corresponding max term. So we have mi is equal to capital Mi bar. So both are complement to each other. Binary index matches the input combinations. So if you see the index terms, they will have the combinations. Like for example, here you will be having a, b, c, which is the product. Here you will have a bar plus b bar plus c bar with the same index m7. We are in the problem number 31 for this third part of the tutorial series. The problem lies in converting to the canonical SOPP form. So we are going to take the function of three variables in the form f is equal to a plus bc, and we want to obtain to canonical SOP, that is sum of product form. How do we obtain the solution? So let us go with the first step. Here we expand the term a because b and c is missing in this particular term. So we can add the one expression in product with a. So a can be written as a into b plus b bar, because b plus b bar is equal to 1. So a into 1 will be a itself. Now if we expand this one, we get ab plus a b bar. So expansion of this one, we got it. Now this ap term, if we take it, and here the c is missing, so we can have c plus c bar as the product, which is again 1, and then we expand this term, we get abc plus abc bar. Now if we take ab bar, here c is missing, so we take c plus c bar, the product with a b bar and then expand it, we got in this form. So in the second step, we expand the term bc, which is having the missing term as a in here. The a term is missing. So we have bc into a plus a bar. So this is equal to 1. And we expand this one, we get abc plus a bar bc. Now we combine and remove the duplicates. So in this particular expression, if we put the f and then whatever we have received in the step number 1 and step number 2, we put it, and then we take this expression and remove the duplicates. What we find is that we have total 1, 2, 3, 4 and 5 terms. So what are the index of these terms we have? So we have, since we want to represent in the sum or product form, we are basically having the small cap letter, which is M3, M4, M5, M6 and M7. These are corresponding to these expressions that we have in the F complete form. And since we have to represent this in the sum of product form, so we can represent this one as a summation here, and then M is the index which is having in bracket all the indexes that is present in this particular expression. In problem number 32, where we had the sum of product which we got from the truth table. So we have a truth table with 3 variables a, b, c, and the output is written as f. So we have to obtain the SOP expression from this truth table. What we do is that in the first one, we write the min term for each row where f is equal to 1. So basically first we need to find where the value of f will be equal to 1, and we see the index terms there and try to write that. So here we have the first index term where it is 1. So this is first index term, this is second, and then we have the third, then we have fourth, and then we have sixth, and we have seventh. So starting from 0, if we count it, these are the index terms where we are getting the output or f expression to be 1, and these index terms we are taking and then we are putting in these index terms as in the summation of f. Now M1 is a representation of a bar b bar c, M3 is a representation of a bar bc, and so on till M7. So the function of 3 variables a, b, c in the SOP form we can write. So here we have the summation and then all the indexes that we have 1, 3, 4, 6 and 7, which makes the f to be 1. So this is the simplified form can be obtained using the Boolean algebra. So still we can do the simplification as we have studied in the previous tutorial. We can still simplify this expression by taking the cofactor, expanding it and doing some simplification. Problem number 33, we have to SOP to POS conversion. So given the expression with 3 variables a, b, c, so we have the summation and the indexes are 1, 3, 5 and 7. Let us try to express this in the form of POS. So product of sum. Given SOP, we have to obtain the product of sum. So in the first step, we identify the missing min terms where the f is equal to 0. So if you observe this one, where the f is equal to 0, we are missing with 0, 2, 4 and 6. So these terms are missing because here f is equal to 0. So convert the max terms using this relationship. So what we do is that now here we have the product symbol and then we have capital M, which is the representation of index for POS, and these terms are missing 0, 2, 4, 6 for f to be 0. So write out the max terms. Now we have the product of these indexes what we have here, and we know that M0 is equal to a plus b plus c, M2 is a plus b bar c, and that product we are trying to obtain it. So this is basically what we have, the product of sum. So we can represent our answer in this format or we can represent our answer in this format. But we have not simplified it in a simpler format. Still we can do it. So after simplification, our final expression that we get is f equal to c. I'm not doing here the intermediate step. You can find out in the Boolean algebra simplification process and you can do it yourself. Problem number 34, where we have the POS that we obtained from the truth table. So we have the problem to obtain the POS expression from the function with F0 at row 0, 2 and 5. So first you write the max term for each row where F equal to 0. So at a row 0, it is already given in the form of truth table. So at a row 0, A will be 0, B will be 0 and C will be 0. So your M0 will be equal to A plus B plus C. And then we take the second index term row 2 where you have A0, B1 and C0. The second index terms in POS we have A plus B bar plus C. Third one we have 5. So row 5 we have A1, B0, C5. The M5 expression that we have is A bar plus B plus C bar. So once we have obtained this, we can easily obtain the product of these terms and then put it here. That will be the product of sum. So the answer, we can represent the POS of 3 variable ABC from the truth table is the product of the capital M represent the max terms, so 0, 2 and 5. And alternative notations, if you want to write, so this is in the form of POS. If we write in the form of SOP, then the product will become the summation. Capital M will become small m because the index terms are represented in small caps. And all the missing terms what we have 0 to 5. Apart from that, we have 1, 3, 4, 6 and 7. These are the terms which are missing from the truth table, so that we have in the SOP form. Now, if we want to convert the non-standard to standard SOP, this is problem number 35, where we have a function A into B plus C. We want to obtain the standard SOP form. So what we do is that first we distribute this to get SOP. So if this expression is distributed, we get AB plus AC. Now expand the AB because in this term we have the missing C. So we do C plus C bar product with AB because this is equal to 1 and then we expand it. Similarly, in this term AC we are missing with B. So we do the product B plus B bar and then expand it. Now combine the expression, we see that ABC appear twice and write it once. So we get this expression. If you observe, this expression is not in the standard form, but this expression is in the standard form of SOP. So your final answer would be, you are basically representing that in the product and then, in the summation format. And then we have a small m, which is the script index terms, which we have, that is 5, 6 and 7, because these are representation of 5, 6 and 7. So that you have in the standard SOP format. In the conversion between the SOP and POS, which is our problem number 36. So we have 3 variable A, B and C. This function is represented in the SOP format because we had summation with the index term 0, 2, 5, 7. We have to find the canonical SOP and the canonical POS. So if you see the canonical SOP format where we have the 4 variables M0, M2, M5 and M7, which are in the summation format. So we can put it in the corresponding canonical form. So these are the canonical forms that we have for 0, 2, 5 and 7. And for canonical POS, what we have the term missing here, that is 1, 3, 4 and 6. So the max terms will be used, that is 1, 3, 4 and 6. So product of the capital M index terms of 1, 3, 4 and 6. And one representation is A plus B plus C bar. 3 representation is A plus B bar plus C bar. And 4 and 6 representation. So we can obtain the canonical SOP and POS given the expression. Answer is both form represent the same function and both are related to each other with the complements. In the next tutorial part, we will see the NAND and NOR gate realization. Those are basically the universal gates. And then we will complete this discussion on digital circuit tutorial series. Thank you for now.